Alright, so now what we are going to look at is how to insert somewhere in the middle of the array. So we are going to focus specifically on that for loop in the insert at index function. So let us assume an array list basically that looks like this, implemented using an array with max size 8 and end of array is 4. That means it has elements from index 0 through 4. And let us say I want to insert at index 2 and the data that we want to insert is 30, right? So we are now looking at this for loop and the code below that because the top above that is what we just saw, resizing insert index if it fixing the insert index if it is invalid value, and that will really make the data to be inserted at the end of the array, and we saw the logic for that, and then resizing the array if the array is currently full. So here even if the array is full, we assume we have resized it, and now really we are going to focus on this for loop on how to insert into this array, okay, and specifically somewhere in the middle of the array. Let us say insert index is 2. So we'll start with index equals end of array, which is 4, and so index is 4, and is it greater than or equal to insert index, which is 2? The answer is yes. So we'll get inside the for loop, and you see what I'm doing here. I'm saying array of index plus 1 equals array of index. So that means array of index plus 1, index is currently end of array, which is 4. So index plus 1 means 5. So array of 5 equals array of 4. So I'm basically copying this value at end of array, which is this where the index is, to the next index. So 37 is basically copied to the next index. Is that clear? So index is 4. At index plus 1, I am copying the value at index. So at index plus 1, which is 5, I am copying the value at index. So 37 is copied here. And then I go to this decrement portion and say index minus minus. And I come back to the condition and check if the new value of index, which is now going to be 4 minus 1, 3, is it still greater than my insert index, which is 2? And yes, so 3 is still greater than or equal to 2. So this is how the array is now at the end of the previous iteration. Now what I'm going to do is index is 3, I get inside the loop and say array of index plus 1, which is going to be 4, equals array of index, which is 3. So I'm copying the value at index 3 to index 4. So this 37 at index 4 is going to be overwritten with the value at index 3, which is 17. So essentially you can see basically I'm copying starting from end of array every element to its right. I'm copying the value of that element to its right. So initially 37 is copied to its right. Now the 17 is copied to its right. So it is now 17 at index 3 as well as at 4, and then this 37 is no longer at index 4, but it is now at index 5. So index is 3. We'll go back and see if we can decrement it. Yes, and then index becomes 2. 2 greater than equal to insert index. Insert index is also 2. Yes, 2 greater than equal to 2. Still true. So come inside the loop and say array of index plus 1 equals array of index. So index is 2, index plus 1 is 3. So whatever the value at index, which is 13, we are copying to index plus 1. So this 17 is getting overwritten with this 13. So the array now looks like this. At index 3 we are going to have 13 instead of 17, and at index 2 we are going to have this 13. Now go back and again decrement index. So index is now 2 minus 1, which is 1. We'll check 1 greater than equal to 2. So 1 greater than equal to 2 is false. So that's the time we come out of this for loop, and insert index is 2. That's not changed. So array of insert index, which is 2, is now set with the value that we want. So at index 2 we are now going to write the 30, the new data, instead of 13. you're going to have 30. So basically you can see every element starting from index 2. So if you want to look at the big picture here, so we want to insert at index 2, right? So all these elements have to be shifted to the right so that the 30 can be inserted here. And how are we shifting the elements to the right? This is how we are doing it. We are starting from the last index, which is end of array, and copying that value to its right, and that's what we have done here. And then so basically write the loop that goes, you see the loop index runs from end of array to insert index. So if I show the arrow here, the direction, basically we go like this. So we will start with index to be end of array, which is 4, and copied the value to its right, and then moved the index to be 3 and copied whatever the value at index 3 to its right, which is at index 414, and then reduced index to 2 and copied that value to its right. So 13 is copied to the right. So now at index 2 we can write the 30. So the other elements starting from index 2 have now basically shifted by one position to the right. So this is now the new array. New array means the contents of the array at the end of the insert operation. So again, we are doing it on the same array, starting with what we had. We have just shifted the elements to the right, and this is now the new array and the current list. Okay. Any question on this? How we insert at any index? So this is important to understand. Okay. All right. So let us continue. So work out like this I show in the slide, so that will be easy for you to follow through. Alright, so now let us focus on the time complexity of this insert operation. Okay, so for time complexity, we typically find out what is the best case and worst case and see if they are the same, and then decide what notation we use. Alright, so the best case would be, as we just went through the whole process, like this is the insert at index function, right? These two check cannot be avoided. We have to reassign insert index to a valid value and then resize the array if needed. But this is something that could be avoided. So we avoided this for loop if we really want to insert at the end of the current array, right? So inserting at the end of the array is the best case scenario. Okay. So let us see that. So we went through that. So if you want to insert at the end of array, which is at end of array plus 1, because end of array really has the index of the last value that is currently in the array. So end of array is 4 in this example. So if you want to insert at index 5, we won't go inside the for loop, because index is end of array, which is 4 greater than or equal to 5, not true. We won't go inside and simply come out of the loop and say array of insert index, array of 5 equals the data, and that's the insert code actually, right? So a simplified version of insert index is the insert code. So that's the best case. The worst case will be then what? Will be inserting at index 0, that is the beginning of the array. If we want to insert at index 0, think about this for loop. What it will do, index will be equal to end of array 4, 4 greater than or equal to 0, true. So we'll come inside and copy the value at index 4 to index plus 1. So we'll be copying that 37 to the right, and then at index 3 we'll be copying the value to index plus 1 to 4. So we'll be doing this copying thing for every index starting from index 4 all the way to index 0. We'll be copying the value at index 0 to index plus 1, which is 10. So once we are done like that, index will be 0, now decremented, it will be -1. So -1 not greater than or equal to 0. So 0 is our insert index. -1, which is the current value of index, not greater than or equal to 0. So come out of the for loop and say array of 0, which is insert index, equals the data. So the at index 0 we are going to have the data 30. So this was our array to begin with. We have basically shifted every element to its right, and then we have inserted the 30. So how many times we have to shift or basically copy the values, right? So copy the values to the right. So that corresponds to, if we check this, we start from index 4, which is end of array. So 1, 2, 3, 4, 5 times. So end of array is 4, we do that 5 times. So basically we can say the number of copy operations we do is end of array plus 1. And end of array plus 1 can be our at most max size. So for example, if we had elements up to index 6 and we would have shifted all those elements to the right and inserted the new element at index 0, the array will be full. So if end of array is 6, we'll be basically doing 7 copy operations. So that could be actually at most max size minus 1. Doesn't really matter, because max size is the size of the array, so that's the upper bound, right? So the time complexity, how many times we could do at the worst case, we'll do n minus 1, max size minus 1 or n minus 1. So the best case is not doing any copy operation, we'll just write at that index. The worst case is copying the values n minus 1 times, basically starting from end of array, we'll be copying the value to the right. So we can say the best case is different from worst case, so we'll use the big O notation. That's the only asymptotic notation we can use if the best case and worst case are different. And we have to say it is worst case n minus 1, but you should know that we cannot have more than one term inside the asymptotic notation, so we can discard the lower order terms and simply say it is big O of n. Okay, so that's the time complexity for the insert operation. So let me, based on what we went through, you should know if they ask in an interview at what index it will take the maximum amount of time. It is at index 0. If you want to insert at the beginning of the list using an array, it will take the maximum amount of time. If you want to insert at the end of the list, it can be accomplishing what is called constant time. We don't have to do any copy operation. Right? Any question on this? The time complexity of the insert operation. Okay, so let us see this issue. So you may be wondering why we double the size of the array. Why can't we just increment the array size by 1? Now that we have gone through the entire process of resizing and all those stuff, so think about, instead of doubling the size, let us say I increment the size of the array by 1. So let us take a very basic scenario. The max size is 1 and it is full, the array is full with some value here. The base address is 100, so the array pointer is storing that address. Now I want to add one more element to this array. So we cannot do that with the current array, so we have to create a new block of memory. Let us say it is created at address 200, and the array pointer will now point to that new block at the base address, and the values from the previous block of memory have to be copied to the new block. So the 20 has to be copied to the new block, and then we insert our new data, which is, say, let us say 45. So this is our new list and the array, corresponding array. So now let us, and max size is 2, right, because it can hold only 2 elements. Now I want to again insert one more element to this list, which I cannot do with the current array. So I have to create a new block of memory and make that array pointer to point at new block. Let us say it's 500. So max size is 3. So every element from the previous block of memory has to be copied to the new block, and then we write this new data, which is 12. Now I want to insert one more data, which I cannot do with this current array. I have to again increment the size and create a new block of memory. Let us say it is starting from 300, and copy all these things from the previous block to the new block, and then write the data. So you see here, I am creating basically every time I want to insert a new element to the list. The array is currently full, so I have to create a new block of memory. So I am allocating basically lot of memory cells for my list, and of course I have to make sure I am clearing all those cells. And if as a developer, if you make the mistake of not clearing those cells, you'll be unnecessarily allocating more memory cells. Okay, so let us assume in this analysis we are not clearing the previous memory cells. And even if we explicitly call the delete function, okay, the operating system will take its time to clear those memory cells. So that's why as a good programming logic, we won't recommend incrementing the size of the list by 1. Even if you're creating the previous blocks of memory, that's not a good logic, and we'll see why it is right away as we discuss this time complexity. You see here, I am going to need to still copy the values from the previous block to the new block, and that cannot be avoided, right? So I have to still copy the values in the previous block to the new block every time I resize or increase the size by 1. So time complexity will be still there to do all those copy operations, even if you're clearing the space. Okay, so if you think about how many new memory cells will be allocated overall, that will also give you how many times you are copying from one previous block to the new block. So let us do that. So let us say if we want to eventually store 4 elements, how many memory cells I am creating? 1 memory cell here, 2 cells here, 3 cells here, 4 cells here. So basically 1 plus 2 plus 3 plus 4, 10 cells. If I want to store 8 elements, I will eventually end up using these many cells, 1, 2 up to 8. So you should know, probably if you know this formula, 1 plus 2 up to n. In math it is n times n plus 1 2 over 2. That's a formula, and this is theta of n square, because n times n plus 1 over 2 is like n square plus n. So n square is the most dominating term, n is the less dominating term, so we'll just retain the most dominating term, which is n square. And I want to write a tight bound, so I use a theta notation and say this is theta of n square. So what you should basically know is, if you increment the size of the array by 1, you will be using or allocating these many cells, n square, theta of n square amount of cells, memory cells, to store your elements. And that's also the time complexity for this copy operation, because these are the number of copy operations you will do, basically also copying from the previous cell to the new cell and so on. On the other hand, if you double the array size, okay, so double means also 2, so I shall just say doubling the array size. So increase by a factor of, well, I'll just say doubling the array size. Okay, so if you're doubling the array size, what we are doing here, you're having an array of size 1, it's full, we are making it twice the previous size, so this is max size is 2. If it is full, make it max size to be 4. If it is full, make max size to be 8. And now let us say how many memory cells you are using. It is 1 plus 2 plus 4 plus 8. So 1 plus 2 plus 4 plus 8 is 15. The previous case I said if you want to store 8 elements, you will end up using 8 times 8 plus 1 over 2, which is 36 cells. Whereas if you double the size, you will be using only 15 cells. And this 15, if you are using n to be 8, if you are storing at most 8 elements, you get 15 cells, which can also be written as 2n minus 1. So we'll skip this math. If you want to go through it, it's fine, you can go through it for understanding, but if you take the next class in 323, we'll go through this math. I don't want to confuse you with this summation formula right now, okay, but go through it if you're interested in this. That's why I put it here. So in general, if you have 1 plus 2 plus 4 plus 8 up to some n, but you see this n is like a multiple of 2, right? So the next will be 16, 32 and so on. So it's a square of 2. So we'll be basically using 2n minus 1 cells, and 2n minus 1 is theta of n, not theta of n square. And that's the take home message for this course. if you are basically incrementing by 1, you'll eventually end up spending more time as well as using more memory. On the other hand, if you double the array size, even though it looks like you're basically allocating more memory, the answer is no. Overall, if you keep on, if you all you want to do is keep on inserting to the list, then it's better to double the size like this instead of increasing the size by 1. And you'll be spending only theta of n amount of memory instead of theta of n square. Okay. Any question on this before we proceed? And what? Yeah, one second.
So you save memory.
Yeah.
So you save memory by doubling it.
Yes, you
rather than
eventually
just
save
increasing
memory
it,
by doubling instead of increasing the size by 1. And you also save memory as well as time, because time is also an issue, right? Because you have to copy every time you increase, create a new block of memory.
Right.
Okay, so let me stop and